Welcome to MRL. In this learning session, we'll be learning about the cube numbers, the different questions from page 12 to page 17 will be answered. Now, this is again the second part of the answers of the questions on different pages of the chapter Squares and Cubes of Ganita Prakash grade 8th textbook. Now, come to question number 1, page number 12. Is 9 a cube is the question. Now, what are the factors of 9? 3 into 3. There are only two factors. Because there are only two factors, 9 cannot be a cube because it has to be a triple if it has to be a cube. And therefore, because the definition of cube is a number which can be expressed as a product of three equal factors. There are only two factors here. Therefore, 9 is not a cube. Now, second question, find the number of unit cubes in a cube with an edge length of 4 units. We have been given a bigger cube which has got a side length of 4 units, and then the volume of that or the cube of that will be 64. A cube of unit length will have volume of 1. So when I divide 64 by 1, I'll get the number of cubes of unit lengths, and that is 64 unit cubes. A very simple example, remember that. What patterns do you notice in cubes of numbers? What patterns do you notice in cubes of numbers? The digits in the units place of cubes is the same as the digit in the units place of any number except for cubes of 2, 3 and 7, 8. Please refer the basics in the cubes video of this particular topic, which is available on this channel. Now, cubes of even numbers are even and cubes of odd numbers are odd. Remember that. Now, coming to the next question, question number 4, page number 13. What are the possible last digits of cubes? The last digits of cubes can be 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. For all unit digits of the number, the cubes have the same digits except for 2, 3, 7, 8. For 2 it is 8, for 3 it is 7, for 7 it is 3 and for 8 it is 2. This is a table which we have already discussed in the subject video of this particular topic. Now, can a cube end with exactly 2 zeros? 10 cube is 1000, there are 3 zeros. 40 cube is 64,000, again 3 zeros. Therefore, the end zeros are either 3 or multiples of 3. They will never end in 2 zeros. Now, to find the sum of the consecutive odd number starting from 91 plus 93 up to 109, that is 10 odd numbers. So since 10 odd numbers are added, we get 10 cube because the sum of n consecutive odd numbers is n cube. Therefore 10 odd numbers is 10 cube, and that is 1000. Now to question number 7, to check if 3375 is a perfect cube. For this, find the factors, prime factors. We find here 3 is a triple, 4 is also a triple, 5 is also a triple. 100% 3375 is a perfect cube because it is a product of two triples here. The factors are triple, therefore it is a perfect cube, and the perfect cube is the cube is 15 cube. 15 cube is 3375. Is 500 a perfect cube? Again, find the factors of 500. The factors of 500 are 2 into 2 into 5 into 5 into 5, and we find only one triple here. 2 is not a triple, therefore 500 is not a perfect cube. Find the cube roots of the following. Cube root of 64. Find the factors of 64. We have 1, 2, 3, 1 triple of 2, 2, 2, 2, again second triple of 2. Now pick one factor from first triple, one factor from second triple. 2 into 2 is 4, therefore cube root of 64 is 4. Now find the cube root of 512. Again find the factors here. We have got 1, 2, 3, 1, 2, 3. That means we have 3 triples of 2. So pick one from each, and then it is 2 into 2 into 2. That is 8. Therefore cube root of 512 is 8. Now cube root of 729. Again find the factors. We have 2 triples of 3. So pick one factor from each. That is 3 into 3. Therefore 9. So for cube root of 729 is 9. Compute the successive differences, and what do you notice in this? That is the question. So let us take perfect cubes. 1, 8, 27, 64, 125 and 216 are perfect cubes. That is the consecutive perfect cubes. Now subtract them. 8 minus 1 is 7, 27 minus 8 is 19, 64 minus 27 is 37, 125 minus 64 is 61, 216 minus 125 is 91. Subtract 7 from 19. 19 minus 7 is 12. 37 minus 19 is 18. 61 minus 37 is 24. 91 minus 61 is 30. Again subtract 18 minus 12 is 6, 24 minus 18 is 6, 30 minus 24 is 6. So when we go 3 steps down or 3 levels down, we find all the differences are the same as far as the cube numbers is concerned. Remember that. Now coming to the next topic, that is figure it out. Is a few examples are given under this. Figure it out on page number 16. So let us see how to solve them. Now find the cube root of 27,000. Very simple again. Find the factors of 20,000, or simple the method is cube root of 27,000 will be 27 into 1000, but 27 is 3 into 3 into 3, 1000 is 10 into 2. We have got 2 triples here. So take 3, one factor from 3 the first triple and 10 from the second triple, then we get 3 into 10 is 30. Therefore cube root of 27,000 is 30. Now cube root of 10648, find the factors of 10648. We find there is 1 triple of 2 and 1 triple of 11. Then pick one factor from the first triple and 11 from the second triple. 2 into 11 is 22. Therefore cube root of 10648 is 22. A very simple method. Remember, only you have to find the prime factors. What number you will multiply to 1323 to obtain a cube? Now let us find the factors of 1323 first. We have got here 1 triple of 3, but 7 is not a triple. There are only 2 sevens. That means we have to multiply this by 1 7 to make it a triple. Therefore 1323 has to be multiplied by 7 to make it a perfect cube, and the cube is 8261. And 8261 is nothing but 3 into 7, that is 21 cube. Remember that. Now state true or false with reason. The cube of any odd number is even. It is 100% false, because cube of any odd number is odd. 1 cube is 1, 3 cube is 27, 5 cube is 25. Odd numbers have, the odd number cubes are always odd, and therefore the statement is false. There is no perfect cube that ends in 8. That is false again, because 2 cube is 8, 12 cube is 1728, and so on. So cubes do end in 8. The cube of a 2-digit number may be a 3-digit number. The cube of a 2-digit number may be a 3-digit number. Let us understand this. The smallest 2-digit number is 10, and therefore 10 cube is 1000, and we have 4 digits here. So there is no chance of having 3 digits. The least number, which is a cube, will have 4 digits as far as 2-digit number is concerned. The cube of a 2-digit number may have 7 or more digits. Please understand, the cube of a 2-digit number may have 7 or more digits. Now let us take the highest 2-digit number, that is 99, and cube it. We find the cube is 970299, and the number of digits are 1, 2, 3, 4, 5, 6, and therefore it is 100% false. It has only 6 digits and not 7 or more. Now coming to the next question. Cube numbers have an odd number of factors. Cube numbers have an odd number of factors. Let us understand this with examples. 64 is a cube. The number of factors are 1, 2, 4, 8, 16, 32, 64. It is odd. Cube of 8 is a cube. The factors are 1, 2, 4, 8, even. 27, again even. So therefore the cubes have both the odd number of factors and even number of factors. Okay, not only odd or only even. Now given 1331 is a perfect cube, to find cube root of 1331 by units and tens digit method. So let us understand this. First of all, group 3 digits first. So this is the first group of 3 digits, and the second group of 3 digits is 1 here. Even if it is 1 digit also, it is still a group of 3 digits only. Now when the digit in the units place is 1, therefore the digit in the units place of the cube root will also be 1. Now cut this 331 and take this 1. 1 lies between 2 perfect cubes, that is 1 cube and 2 cube, and 1 is definitely greater than 1 and smaller than 2 cube. Therefore the digit in the units place has to be tens place has to be taken as 1. Therefore cube root of 1331 is 11. Already you have learned this method in squares and square roots also. So try to remember and apply here. Now we are given a number 4913. We have to find out, again apply the tens and digit method here. 913, first group 3 digits, that is 913. The digit in the first group, the digit in the units place is 3. If the digit in the units place is 3, then the digit in the units place of cube root will be 7. So therefore that is the first digit is decided, that is the digit in the units place is 7. Now cut the 913, take the digit 4. Now 4 lies between 1 cube and 2 cube, and therefore the digit in the tens place is 1. Therefore the cube root of 4913 is 17, because the tens place digit is 1 and the units place digit is 7. Remember that. Now the next example, cube root of 12167. 12167. Take the first group of 3 digits. 7 is the digit in the units place. Therefore, 3 should be the digit in the units place in the cube root. Cut 167. Take 12. 12 lies between 2 cube and 3 cube. Therefore, the digit in the tens place will be 2. Therefore, cube root of 12167 is 23. Remember that. Now next example, 32768. Now group, again take 3 digits. The digit in the units place is 8. Therefore the digit in the tens units place in the cube root has to be 2. We already know that. And the next group is 32. Now 32 lies between 3 cube and 4 cube, and therefore the digit in the tens place has to be 3. Therefore cube root of 32768 is 32. So please remember that. Now the next example is, which of the following is the greatest? That means 67 cube minus 66 cube, 43 cube minus 42 cube, 67 square minus 66 square, 43 square minus 42 square. It is very clearly visible to us here. 67 cube minus 66 cube is the greatest, because the values will be much bigger, because it's a cube number. 67 cube is a cube number, they're much bigger. Let us understand this. Now what do you do? Now let us understand this algebraically. If I take a cube minus b cube, you can express it as a product of factor a minus b and a square plus ab plus b square. But we know that a minus b becomes 1 here. 67 minus 66 is 1, and therefore a cube minus b cube becomes only a square plus ab plus b square. Now put the values of a and b in this. A is 67 and b is 66. When we put the values of a as 67 and b as 66, all are positive values, the sum will be much bigger. Same way, if you put the values of 43 and 42 in this, again the sum will be bigger, but definitely less than 67 cube minus 66 cube. Now next point is, if I take a square minus b square, it can be written as a plus b into a minus b, because it's an identity. But a minus b is 1, so therefore a square minus b square will be a plus b. So therefore 67 square minus 66 square will be only 67 plus 66 and 43 plus 42. Just understand here, 67 plus 66 is a very less value, very low value when compared to a square plus ab plus b square. And therefore both of these two, the third and fourth, are definitely not the greatest. But comparing these two, 67 square plus 67 into 66 plus 66 square, definitely this value will be much bigger than 43 and 42. Therefore 67 cube minus 66 cube is the greatest value amongst all the four. So try to apply this algebraic relations to understand the thing. Otherwise, by inspection itself, it's very clear 67 cube minus 66 cube is the greatest. So these were a few questions asked on different pages, from page 11 to page 17 of the textbook. We have answered them. Go through them, understand them, practice them, remember them, note down the answers in the notebook for your reference. Okay, thank you.